Hello, we're going to talk about Diels-Alder dienes and Dienophiles today, just as a supplement to what we talked about in class and in addition to some of the things that you learned in Orgo 2. So the three retrons that we're going to look at are these here, and these are compounds that are a little bit challenging to make when we think about traditional Diels-Alder reactions. So let's work through them and see what we come up with and see what tricks and interesting things chemists have developed. So this first one, if we try to look at that, how we would make it by a Diels-Alder reaction, we would do our retrosynthetic analysis and say that that would come from a standard diene, and then our dienophile would be a ketene. All right, that looks like a pretty reasonable reaction. The only problem is that ketene undergoes 2+2 cycloadditions, not 4+2 Diels-Alder. Right, so this will participate in 2+2 cycloadditions. So we need something that is a ketene equivalent, all right? And that's the trick to making this compound. So what we would do instead is that we would react the same diene, but with a different dienophile, right? And the dienophile that we will use is one that looks a little bit strange, right? But we'll see how it goes. So it's a cyanoacetate, all right? And that is a ketene equivalent. Right, so if we react those together, standard Diels-Alder reaction, and then we get that compound. Right now what we can do is treat that with base. So we can add sodium hydroxide to that. All right, and when we treat it with base, then it will turn into the product that we want. Right, so if we think about what's going on when we treat this with base, right, we're first going to hydrolyze the acetate. Right, so again, remember the acetate is just a ketone, so it's an ester group here. Right, acetate's a carbonyl. So that gets hydrolyzed. So we end up with this. All right, so hydrolyze the ester, right, of the acetate group. That gives us an O-, and then that can form the carbonyl, Cn- as the leaving group, and we get to our product. Okay, so that's a really nice example of how you can use something that's an equivalent of a ketene and then get to the product that you want. All right, so that might be useful when you're working on some problems. Okay. All right, so the second one is when you look at something like this, right, a cyclohexenone, right? And we've talked before about how cyclohexenones, these are retrons for the Robinson annulation. We've not talked about how to make these things in the Diels-Alder reaction, right? But this is a retron, let's say for the Robinson annulation and for the use of Danishevsky's diene in the Diels-Alder reaction. So Sam Danishevsky developed this as a really nice way to make substrates like this using a Diels-Alder reaction. And so the key when we're thinking about retrosynthetic analysis is to recognize that this functional group, the enone, can come from something different, right? And then it will look much more like something we can make by the Diels-Alder reaction, right? So where it comes from is, keep the W group in the same spot, and if we have a silyl-enol ether here and an ether in that position, okay? And so that we can now make by a Diels-Alder reaction. And here is Danishevsky's diene. All right, a very useful diene in the Diels-Alder reaction. And when you do the reaction and you end up getting to this point, how do you turn it into the final product that you want? You just have to treat it with acid. right? And so it's a very simple reaction to treat this with acid, and you get there. And when you think about what happens to get to the product, right? So let's think about, we'll do that over here, right? You'll end up protonating the ether, right? So you protonate the ether, you can then have the silyl ether, push that out as a leaving group. And all you have to do is have water attack, and that will bring you to the final product. Right? So let's just say to our product, and the water can attack the silicon, and then give you the carbonyl product that you want. So very easy to transform compounds that look like this into the cyclohexene, right? And that's the use of Danishevsky's dyeing. And the final one to look at is if we want to make something that looks like this, right, where it's a tetrahydronaphthalene structure, so benzene ring attached to a 6-membered ring, right? And the question is, how do you end up making this, right? And so if we do our Diels-Alder disconnection, right, we would say that's the Diels-Alder reaction that we want to do. These sorts of compounds are very, very reactive. You can't buy this. So this is something, because you no longer have the benzene aromaticity, it very quickly will revert to benzene by some sort of reaction, and you have to make these things in situ. So the key thing to think about is, how do we end up making dienes that look like this, right? And if you remember, we've done this before in Orgo 2, right? And so the way to make those dienes is if you have a benzene ring fused to a 4-membered ring, right? And we talked about how you can do this with an electrocyclic reaction, right? And so if you just heat up that compound, it'll do an electrocyclic ring opening, and that will give you that compound, right? So that's a really popular way to do it. Another way to do it, and we've seen this too when we talked about, we've seen things like this when we talked about forming benzene. You can start with a compound that looks like this, where we've got a trimethyl silyl group in this position, and then some sort of leaving group, and in this case we'll have ammonium ion. And if you take this and treat it with fluoride, that will attack the silicon, and then you can get an elimination type process to occur where you lose ammonia, or sorry, trimethylamine in this case, and that gives you the dyene that you want, right? So again, these are really useful strategies to make some interesting dienes and dienophiles. So again, the first one, we make a ketene equivalent, which will prove useful in some cases. These two dienes are especially useful, the Danishevsky's dyene, and then this dyene that enables you to make these naphthalene type structures. So these should be useful as you work some of the problems that you're working on for this week.